right, so here is the video I promised you on intermediate value theorem. Again, I really just want you to watch this video, try to let it sink in, and we will talk about like how to use it, I guess. I mean, I'm going to show you some examples, but in terms of like maybe something in Delta Math or some book work, we can hold off on that till class. But please, like for my in-person folks, please bring your book to class with you. Okay, so we're going to be talking about the intermediate value theorem, and you can abbreviate that IVT. That is appropriate even for the AP exam. They know exactly what IVT stands for. So let me tell you what it is, and then we'll talk about like what it means graphically, and then we'll talk about like how to tell if it applies and that sort of thing. So here we go. All right, so suppose f is, or you can say f of x is a, excuse me, not is a, just is continuous on a closed interval from A to B. Okay, so that's why we just went over like how to determine if something is continuous on a closed interval, because it has to be continuous on that closed interval for the intermediate value theorem to apply. So suppose f is continuous on that closed interval. If k is any number between f of A and f of B, okay, then there is at least one number, let's call it C, in that closed interval, okay, such that f of C equals k. All right, now that's a lot of weird letters in there, so I just need to make sure that you understand what everything stands for. Okay, so when I say it's in the closed interval from A to B, these are x values. Okay, so down here, A and B are x values. So if I'm talking about a C, a number C in that interval, C is also an x value. Okay? But then we have this K and this f of A and f of B. Well, f of A and f of B, that means what do you get when you plug A into the function and B into the function? So these are y values. And if I say something that like K has to be between those, then K is also a y value. Okay? So I just want you to understand that that's what we're talking about. So then when we get to this end piece here, those are y values. Okay? Talking about y values there. All right, so let's put this on a picture and see if I can explain it a little bit differently. Okay, so let's say we just have this random, or I'll just put something in the first quadrant, and I give you, like I have some continuous function, and it's continuous on the closed interval from A to B. Okay, so those are the x values of the endpoints. So then the y value here would be f of A, and the y value for this one would be f of B. Okay? Well, what this is saying, what this theorem says, is as long as my graph is continuous on that closed interval, if I have some k value anywhere between f of A and f of B, then there has to be an x value, okay, we'll call it C, that corresponds to it, and that C has to fall in between, it has to fall inside that original interval. Okay, so Go away, box. I just want the box to go away. Okay. So I could say then that what if the K was up here? Well, then it would also have, might be way over here, but it would also have a C value, an X value that corresponds to the point on the graph, okay? And so as long as my graph is continuous, all right, and the given Y value is in fact between f of A and f of B, then it has to correspond to a C value between in the original given closed interval. Okay, those are X values. All right, so hopefully you can follow that. If not, you might need to listen to it again, and then maybe just applying it will help. All right, so we're going to look at some examples. Okay, I don't like red unless I'm trying to point something out. All right, so for my examples, I just want to know, does the intermediate value theorem apply on the closed interval at the given K value? Okay, and then if so, all right, we're actually going to find the value of C guaranteed by the theorem. Okay, so first example, I'm going to give you a piecewise. Okay. And give you a little bit more information about it. All right, and we're going to put that on the closed interval from 0 to 3. And I'm going to go ahead and tell you that K equals 4. Okay? All right, so I first want to know, does the intermediate value theorem apply? All right, well, in order for the intermediate value theorem to apply, the function has to be continuous on the closed interval. So I want to know, is f of x continuous on that closed interval? All right, and so then you need to go through the process of how do you check that? Okay, how do you know? Well, it has to be defined everywhere in that closed interval, including the endpoints. Well, 0 is defined here, 2 is defined here, and that's where it breaks. So everything in between is defined on the top line, and then everything from 2 to 3, and 3 is included in the bottom line. All right, so everything from 0 to 3 is accounted for, and plugging in any of it, none of it will give me like some undefined or imaginary number or anything like that. Okay, so it is defined. Well, then I want to know if it's continuous on the open. Okay, well, when you have a piecewise, the one place that you're going to be really concerned about being continuous is where that piecewise changes. Okay, so we know that f of 2 exists, right? So we're checking 2. All right, and we know that f of 2 exists because we just said it earlier, but it's because you can plug it into the top line, okay? And then we want to know, does the limit as x approach 2 exist? But because that's where the piecewise changes, I have to show or check to see if the limit as x approaches 2 from the left and the right are equal to each other, okay? Well, the left of 2 uses the top line, and the right of 2 uses the bottom line. And when I direct substitute in, I get 1 equals 4, okay? Well, that means the limit as x approaches 2 does not exist. And if the limit does not exist, then the function is not continuous, okay? So is the function continuous on that closed interval? No, it is not. Therefore, IVT does not apply. Okay? And that one's actually done, because if it doesn't apply, you can't do anything else with it. Now, it's not saying that there isn't a value of C between 0 and 3 that would give me a y value of 4, but it's saying it's not guaranteed by the theorem. Okay? All right, so let's do another one. All right, this time I'm going to say that g of x equals 4 plus 3x minus x squared. And I want to look at it on the closed interval from 2 to 5. And I'm going to give you the y value that k equals 0. Okay? And so remember, in order to figure out if IVT applies, the function must first be continuous on the closed interval. So these are notes. So I'm just like making sure that you understand. I want to know, is g of x continuous on this closed interval? And yes, technically there are a lot of steps to this, but g of x is a polynomial. Okay? This is a quadratic function. It happens to be a downward parabola. And hopefully you know that those are continuous everywhere. So this is definitely continuous. And you can tell me that you know that because g of x is a polynomial. All right, and that's continuous everywhere. Okay? So this time we got past step 1. So then step 2, or the second part to this, is to make sure that k is k between f of a and f of b. Okay? All right. So that means I need to actually find those values. Well, a is 2, so I got to find f of 2, and b is 5, so I got to find f of 5. Remember, my interval is a and b. Okay? So if I plug 2 in, or I guess that should be g. Hopefully you know what I'm saying. All right. Those should be g's. G. Okay. All right. So g of 2, let's see, would be 4 plus 6 minus 4. And g of 5 would be 4 plus 15 minus 25. 19 minus 25 is negative 6. And they don't have to go in order. I just want to know, is the k value between, okay, so here's my k, is it between those two numbers? And in this case, it's actually g of 5, which is negative 6, okay, is less than 0, which is less than g of 2. That just means it's a decreasing function, but you don't have to worry about that. As long as the k value is between those two y values, you're good to go. Okay, and so as long as those things, as long as we can say we can do both of those things, then we can say, therefore, IVT applies. Okay, and that was the first thing I asked you. Does IVT apply on the closed interval? Okay, well, then I asked you, well, if it does apply, I want you to find the value of C guaranteed by the theorem. Okay, so to find C, all right, what you're going to do is you're going to set, all right, g of x, or whatever the function is, equal to the given k value, and solve for x. Okay, you are going to set the g of x function equal to the given k value, in this case it was 0, and you're going to figure out how to solve for x. All right, so this is just a quadratic function. I am going to choose to move everything to the right. All right, so then my x squared is positive because that makes it a lot easier to factor, and then I can just move the, because if it's equal to 0, it doesn't really matter what side it's on. And this factors into x minus 4 and x plus 1. So x equals positive 4 and negative 1. Well, then you have to make sure that those answers, and they both could be, but you do have to make sure before you tell me what C equals, that these have to be in the given interval. Well, negative 1's not in the interval, so C can only equal 4. Okay? So whatever C equals must be in the given interval. And so, but if both of them were in there, then C could be two different values. Remember, the theorem just guarantees that there's at least one. Okay? Hold on a second. Let me. All right. Sorry, I was just looking at my notes to see if I wanted to go over the other piece that I have here, because I want to talk about how this might look on the AP exam, because the intermediate value theorem comes up a lot. Like almost every single year, there's a piece of the free response questions that you need to refer back to the IVT, the intermediate value theorem. So I just feel like it'd be best though if we looked at that together. So that's going to be it on the intermediate value theorem. I know I promised I wouldn't give you an assignment, but if you want to kind of look ahead and get an idea of the book work, you're going to be looking at page 81, 95 through 98. Okay? And the notes that we took here are enough for that. But the extension to like how it might look on the AP exam, that doesn't come into play with the book work. So you would be fine if you tried to start that ahead of time. Otherwise, I will see you in class for practice with the IVT.